In this video, I'm going to show you how to take the derivative of an integral with limits of integration that are functions of x. So let me show you what that looks like. We have d dx of the integral. I'm going to call the lower limit h of x and the upper limit g of x. And the integrand is f of t dt. Now, in order to evaluate this expression here, we need to make use of the fundamental theorem of calculus, part 1, that says that, so if we take the derivative of an integral that goes from a constant c to x, f of t dt, this is equal to f of x. It basically says that the derivative and integral are inverse operators, so it cancels out, leaving only f of x. All right, so let's, I'm going to use the properties of integrals now in order to evaluate this derivative here. So first I'm going to split up the integral into two. So d dx, I'm going to make the first integral go from the lower limit h of x to a constant c, f of t dt, plus integral. I have to pick up where I left off, so from c to the upper limit g of x, f of t dt. Now, I need the variable part to be on top, so I'm going to flip the limits of integration in the first integral by introducing a minus sign. So this is going to be d dx, a negative integral from c to h of x, f of t dt, plus integral from c gx, f of t dt. All right, so let's see. Okay, so now I'm going to make use of the fact that the derivative is a linear operator. So I'm going to distribute it to both integrals here. So negative d dx, integral from c h of x, f of t dt, plus d dx, integral from c to g of x, f of t dt. So if you look at the fundamental theorem of calculus, the variable on top is just x, whereas here the upper limits are functions of x. So my next step is to make substitutions in each of the integrals. For the first one, I'm going to say let u equal h of x. And for the second integral, I'm going to say let v equal g of x. Now, because I'm changing variables, I have to, I have this derivative here in terms, with respect to x. I have to use the chain rule to rewrite it in terms of this new variable u. So this is going to be negative. Let me be consistent with the coloring here. All right, so this is going to be negative du dx times d du of the integral from c to u, f of t dt, and plus, for the second term, I'm going to have a plus dv dx times d dv times the integral of from c to v, f of t dt. You can think of it as if the differentials cancel out, which leaves the original d dx. So this is essentially how the chain rule works. So now that the upper limits are single variables, I can apply the fundamental theorem of calculus. So this is going to be negative du dx, and now this part becomes times f evaluated at u, and then plus dv dx times f evaluated at v. And so now that the integration or the differentiation is done, I can substitute back the original functions. So negative du dx, that is negative h prime of x times f, and u, that's h of x. And then plus dv dx, that's g prime of x. And then times f evaluated at v, which is g of x. So here, this is our formula for the derivative of an integral with limits of integration that have variable limits. Thanks for watching.